Sorry about all the delays. I know the stream's been a little flaky right now, and I apologize for that. I hope that this is going to fix that, and I'm hoping all these issues are now resolved. So, let's get started with today's stream and going over what exactly this Season 2 is about. So as you can tell from the title of this video, Season 2 is about C++ again, but this time with OpenGL. So if you remember last year when I did this, we focused a lot on C++ and SFML, which was great for two-dimensional games, but doesn't really work well for 3D games. So for today's stuff, what we're going to actually be focusing on is utilizing OpenGL for 3D game development. Now, as some of you may know, OpenGL is a 3D API. It was designed way back when as a competitor to Iris 3D. Now, I'm not going to go a whole lot into the exact details and the full-on history as to what OpenGL is, what it's used for, and things like that. Well, I'm going to go over some of that, but I'm not going to go into a complete breakdown. If you're interested about the history, however, you can find out more from the following link that I'm going to send out. This has just a bit of the info and is a pretty good link for it. So I'll post this in the YouTube video below, and if you want it in the Twitch chat, feel free to just let me know and I'll give it to you. But it's just a quick little history on it. It kind of goes over some of the stuff. But the basic summary is, back when 3D graphics APIs were kind of limited, IrisGL was a proprietary graphics API, as you can see from there. And what ended up happening was a group of people got together and said, hey, we need a better API for this. And so they formed the Chronos group. Now, they are the ones who manage it. You can access their website. Go here, Chronos, whoops. Chronos group, they manage OpenGL, and some other ones as well. But this is where all the specifications come from. It's a group of people who sit down and decide, okay, you know, this is where 3D APIs are going, this is what we need to make them with, or add to them, or whatever else. And this is where a lot of your stuff comes from. So this is how they define what goes into OpenGL and such. Now, obviously this is going over OpenGL, but some of you have probably heard of another one called DirectX. So DirectX is actually a competitor to an extent with OpenGL. Now, DirectX focuses more on game development graphics, whereas OpenGL generally focuses more on 3D as a whole. So, you know, you might make a CAD editor for designing models for, you know, 3D printing or whatever, and that would most likely be written in OpenGL. Whereas DirectX you're probably going to use if you're making something like the next Crisis or something. You know, you want to do a more game-specific thing. So that leads to the question, why are we doing OpenGL for game development? Well, OpenGL still works great for game development. It's still just as efficient. It just doesn't have some of the bonuses DirectX handles for you. So like DirectX can sometimes handle model loading and things like that, and I want to kind of teach from a lower level on that. I don't want to focus on having an API that will do level loading for us. And so what we are going to do is we'll go over all of that through this series and showing you how to do that. And maybe in the future I'll do something on DirectX, but the big benefit of OpenGL is that it's cross-platform. This will work on Windows, it'll work on Linux, it'll work on Macs, it even works on your Android smartphones and everything else. So this kind of has a nice multi-platform touch to it, which is useful. And yeah, so that's where we're going to use it. So again, these links will be in the description below the YouTube video. You can read them for the history or for updates and stuff. And yeah, so let's go and let's start out today's video. First off, let's talk about the stream. Before we start diving really into OpenGL and everything else, I want to talk about the stream. So last year we did, I did about 10 episodes of this. Each episode we went through and created another game. And the benefit to that was you guys got to see the full game creation process kind of scrunched down into a 4 to 5 hour period. The downside is that that was 4 or 5 hour long videos. That's a lot of time for me as well as you guys to sit through and watch them. So what I've decided to do this year is rather than going through and trying to create a bunch of different games, especially with OpenGL where it's going to take time, I've decided to consolidate everything into one single video. Or in one single game. So the focus of this is going to be on creating several pieces that will go into a larger whole. So the benefit to that, especially now, is that these videos are going to be much, much shorter. I'm not going to be taking multiple hours to do them. It's going to be more of a 30-minute to an hour-long period at most. And so today's video is going to focus on the introduction, but I also want to introduce the stream because there's a lot of things that we have to cover, there's a lot of things I want to go over, but I really want the focus on this to be how do you use OpenGL, how do you make a game in C++, and how do you make it three-dimensional. So there's a lot of neat things we're going to do. We're going to be going over things like how do you render a 3D model, how do you load textures, what do you do to be able to load tons and tons of models without taking up rendering space like in Minecraft. There's a lot of that we'll be going over. But the other big thing I want to also go over is other parts of it. So how do you get a physics engine into it? I kind of did a video on that after last year's stream on how to use Box 2D, but I really want that to be a core part of it so you guys can have nice physics in your games. You know, we can also go over how to write the physics engine, how do you do spherical collisions, how do you do sphere to box collisions and things like that. But I really want you to have the tools to make a proper game. I don't want it to just be something that you throw together to learn how to do it. That is important, of course, but the goal for this is to make it so you guys can make your own games. So we're going to be focusing on how to use OpenGL for rendering to simplify the pipeline with that. We're going to be possibly using, I'm thinking right now of using Bullet 3D, which is a really awesome physics engine. It's been used in Grand Theft Auto. I want to say even the most recent Grand Theft Auto games use it. So it's a very, very well done, free physics engine. We'll also be going over some basic audio designs, but the really big exciting thing that I really am excited for, and I'm hoping this will work out to our advantage, is I really want to do virtual reality with this. I want to teach how to use a virtual reality headset with your game. And so this game will ultimately be a virtual reality game. When designing it, that'll kind of be where the focus goes. I'm planning to use it with the Oculus Rift for sure. I've got a pre-order ready. Hopefully that'll be here in March, which will be perfect. That'll be coming up when we'll be getting to that. I'm also, however, hoping to get an HTC Vive. Now, those do not come out till April. If anyone knows of a way I can get one, I've been trying to sign up for developer programs. They're very limited and very tough. But if there's a way, sorry if I keep looking away to make sure that the stream is okay. So again, if something looks off, just let me know in the chat, guys. And I'm kind of keeping an eye. I'm on an IRC channel as well as this. And I'm also getting some stuff. So I'm also getting some info to correct on some DirectX stuff that I mentioned. DirectX apparently does not ship with as much of the game development stuff anymore. But anyways, continuing on. And it looks like the stream quality could be also causing some of the lag, so I apologize for that. Next time maybe I'll lower the quality down and such. But anyways, yes, going to try and do virtual reality. I'm hoping to get get a hold of a Vive. I don't know if HTC or Valve is going to be able to give me one. If anyone from there is listening, I would love to have one. The biggest thing is I need time to learn the systems. I've developed with the Oculus Rift before, so I kind of know what the APIs are there doing and stuff and what to expect. The big thing is I will need time to learn how to use a Vive. So I'm going to try and get that. I'm looking to try and contact HTC and Valve and see if I can get a hold of one to learn it, because I'd really like to have this support both the Rift and the Vive. And when the game is done, it'll be open source, but you'll be able to play it still, of course. And yeah, so that's the current plan. So long story short, basically we're going to make a virtual reality game using OpenGL and SDL. So that kind of leads into the first part. So OpenGL. Let's go into what OpenGL is. OpenGL is a graphics API. What it does is it talks to your graphics card or to your Windows and then to your graphics card depending on what system you're using. So if you're using Windows in this case, it talks to the drivers and then the drivers translate that into commands for the graphics card. And so OpenGL is really just a graphics API, but it's much lower level than something you would use with a library that's built on top of it. And the way that this works is we basically have a list of OpenGL calls. Now, remember how I said that OpenGL was created way back when in I think it was about the 90s. Don't quote me on that. But basically, when that was created, OpenGL, there weren't a lot of games out there, and there weren't a lot of 3D applications. So OpenGL was a new territory. So a lot of the stuff they invented then ended up changing over time. And so I kind of need to talk about this because this is very, very important in regards to how we're going to handle this. Because OpenGL has two specifications. You have the old specification, which is OpenGL 1.1, 1.0. Really anything below 2.0 is an old deprecated API. You should not be using it. There's a lot of tutorials online that try and show how to use this, and it's not. You do not want to use it. The rendering pipeline is not up to date. It is not modern. And to identify this, it's pretty easy. A lot of times you'll see a GL begin and a GL end with a bunch of commands in between them. This is the old API. And the reason that it's not good is because it doesn't take into account things like shaders and stuff. There's a lot of new modern 3D rendering techniques that use what are called shaders, and we'll go over those in later tutorials, so you don't need to worry about that now. But shaders are a very, very important thing that have really helped to advance 3D graphics. So OpenGL has a lot of bad stuff that's deprecated. So what we need to do is we need to use the newer OpenGL stuff. This is where you start getting into things like vertex lists, where you pass all of your vertices to the graphics card at once, and then you just say, hey, render this group that I gave you earlier. This, of course, is a little problematic. Now, remember I said how DirectX came along? Well, that's made by Microsoft. DirectX is Microsoft's kind of direct competitor. And the problem is Microsoft does not include the latest bindings. They can kind of include a bare minimum for OpenGL to begin with. Really, what you actually have to do to use the new OpenGL stuff is you have to talk to the graphics driver and say, basically you talk to a system in between the graphics driver and OpenGL, and it's this kind of glue layer that basically what it does is it says, hey, you say, I want this command from OpenGL, it's in the new systems, and it says, okay, here's that command. It gives you a pointer back to that where it can access it in the driver. And any command that you want, you have to set this up with. So it's not really a difficult thing to do, and maybe I'll go over it in a future video if you guys are interested on that, but there's a lot of libraries out there that do this for you. And so as a result, the first library that we're going to be using is called Glue. Glue basically is what will allow us to have all of those extensions managed automatically by us, or by the system. So that way we don't have to worry about little things like how do I get the GL set viewport command, or whatever ones we need. I'm not going to really go into all of the ones that are included in by default and not included by default. I'm just going to kind of go over it, but that's the basic summary. So Glue is going to be what actually goes through and does those OpenGL extensions and gets them for us. So that's the first part. The second part is, remember how I said that OpenGL is a graphics rendering library? Remember, that just means all it does is draw via our graphics card. That's it. It doesn't handle things like having a window. This window is another thing that's needed. We have to have a window, and then in that window, tell it, hey, render these graphics to that window. So what that means is we need another set of tools to do that. Now, we could do that using Windows built-in stuff. That's perfectly doable. There's no reason we can't. But in my opinion, it's a little overkill. I think it's kind of silly for us to do that. It's been done a million times, and again, I really want to get this focused on the OpenGL side, especially since there's so many good libraries out there. So what I've gone with is I've decided to go with SDL. Now, SDL is the Simple Direct Media Layer, as it says there. Um, and basically, what this does is this has a, if you will, a set of code that does a variety of different rendering things. But the big things we want from this are twofold. First off, we want to be able to use it for yep, SDL is a fantastic library. It's very straightforward. It's cross-platform. Again, all of this is going to be designed to be cross-platform. That way, you don't have to worry about if you want to work on this on Linux, you can, and so on and so forth. So SDL is going to handle two critical things for us for right now. It's going to handle creating our windows so we can render to them, and it's also going to handle audio for the time being. Once we get to the virtual reality stuff, that is most likely going to change just because of 3D audio and all of the special stuff that both Oculus and HTC and Valve have worked on. But for the time being, we're going to stick around with that for some of our initial things. So we're going to be using these two libraries, SDL and Glue. The third and final thing we're going to be using, again, I'm focusing this on Windows. You can do this in other platforms if you'd like, but because this is Windows, we are going to be using Visual Studio once again. I really just don't want to deal with trying to use a makefile and all of that stuff. It's just not worth the effort for those of you who are used to doing this on Linux and other systems. So what we are going to do is we're going to use Visual Studio, and again, great thing about Visual Studio right now is that the 2015 Community Edition is perfectly free and supports everything we need. If you go and you Google Visual Studio, you can come up here, free Visual Studio, and there you go. So that's all pretty straightforward. I'm not going to go through installing Visual Studio because I've done that before, I think, and if not, it's very straightforward. The biggest thing you need to make sure you have is C++, and you'll be fine. Yes, I am recording this. It should be recorded and uploaded to YouTube later. Yes, it should be. Let me go through. I'm going to double check my settings just to be 100% sure, but it was turned on and it should be. So let's double check. Actually, because I've messed up on the stream so time, I can just go to my past broadcast and we can see it from there. Yep. So that is all there, and these will be exported to my YouTube channel. If you have missed the beginning or something and you're just now coming in, do not worry. It will be on YouTube. Yep. So, yes, all of these will be on YouTube, and for those of you who have maybe missed the first season of everything, you can actually go down in this page and you will be able to see it. If you're watching this on YouTube, I will post it on the description of the video below. So, diving right into this, I'm not going to go over setting up Visual Studio. Visual Studio is pretty straightforward. There's not a whole lot of craziness with it. You know, it's very straightforward. So what I'm actually going to focus on is I'm going to focus on setting up the Visual Studio project, adding in both Glue and then also SDL, and then I'm just going to go find some kind of sample online where we can go through and paste that code into here and be done with it. Now, the other things that this season's also going to focus on, I've been brushing up on my C++ 11, trying to make sure that I'm up to date on all of the new stuff that's been going on with it. So I'm also going to be showing you guys some new tricks for C++. These will really, I think a lot of these are pretty well known about, but I want to make sure they are. They're very, very useful. They really simplify C++ development time. So we'll be going over all those. So yeah. So to start off, I'm going to go ahead and I'm going to open up Visual Studio. We'll get this all loaded up. Hopefully it does not lag my computer too badly. Oops, there we go. Okay, so we're going to start a new project. And this new project, what it's going to be called is, I am simply going to call it, for now, we're just going to call it Demo Project. And this code is not going to be on GitHub due to the fact that it's pretty straightforward. There's not a whole lot of craziness, and I don't really see a reason to put this particular project on GitHub. The final product, when we start coding it, will be on GitHub. but I'm not going to focus on that right now. So what we're going to do is we're going to go through and click Next. Now the big thing we want to make sure we do is I want to make sure that we have a console application. What this does is it makes sure that we're not, if you've seen the previous streams, basically it just brings up a console window that we can hide at leisure. We're going to go through and disable the security development lifecycle checks. I don't really care too much about that. And we're going to make sure it's an empty project. We don't want all of this extra stuff like the precompiled header, that Visual Studio likes to add. So we're going to go ahead and finish, and that's going to go through and create our project for us. And we're all set. So this is our demo project. What we can do real quick is we come in here, add a new item, and we'll just name this main, and that's going to be our main source file. And to go ahead and get started, I'm going to just include the standard IO stream. Include, don't we need... I don't think we need that. Anyways, int main, std cout, hello world, end line. So there's that, and we're going to hold down Shift and F5, Control F5. That's going to ask us if we want to build it. We say yes. It goes through and builds it, and because we held the Control key and pressed F5, that'll go through and stop it, and we've got our nice little hello world ready to go. So we're all done with that. Next up, we need to go ahead and begin. What is that? And that's what happens if you run it normally, which is just quick flash, display it, done. Okay, so we've got our basic bare bones C++ project. Now what we need to do is we need to tie in all these libraries. So what we're going to do is we're going to go back to the web pages that I've linked to previously, and we're going to go over here to download. Once you're at download, we're going to want to come down, and we're going to want to download, actually I think it's on the home page as well somewhere. So we're going to go to here. Here we are. So this is our main home page, and what we're going to want to do is download the Windows 32-bit and 42-bit binaries. This is basically just our basic setup. Now remember, glue is being used to glue is what we're going to use to glue is what we're going to use to actually get all of our OpenGL modern APIs into our project. And I'm also going to go ahead, I'm going to come over to SDL and download this while we do everything else. Now there's a couple things here. First we have the source code, obviously the SDL source code. Then we have the runtime binaries. Now these are very specific. These are not what you want to download. What the runtime binaries are is that SDL compiles everything into DLLs, and then you use those DLLs with your project to be able to actually make the calls. We are not going to need those right now because those come with the development libraries, which is what we want. But these are very useful if you're asking others to play the games. You'll want them to have these. You'll want to probably include them with it. I don't know if you're allowed to. I would check on the licensing and stuff. I would assume you are, however. So we want to go through and download the development libraries. Specifically, we want the Visual Studio versions for Visual C++. And so we're going to go ahead and we're going to download these. And there we go. So, going back to our directory where those were downloaded, what we're going to do is we're going to extract both of these. And we're going to then have a quick look into each one. So starting with glue, we go in here and we've got 3 main folders that we want to focus on. We've got bin, include, and lib. So bin is basically the various libraries. What these are, and I will go over the difference between release and release MX in just a little bit. So this is just some extra libraries. Glue32 is a DLL that's used. We don't really need that straight away. The big things we do need are we need the include here. And actually, we aren't going to need these at all, to be more specific. We're not going to need the DLL because we're going to be statically linking everything to the project, which means that it's not going to be loading from there. It's going to be loading from the library and then putting that code into our program directly. We really need to focus on the include, which includes the header files necessary, and we need the libs. Specifically, we want release. This is going to be using these these library files here. Now, what is MX? So in C++, we have the namespace, and what this does is it puts everything into its own namespace. We could do that for OpenGL, however, that's a little more complicated than I think we need to be with this. I want to keep this very, very simple this year, so we're not going to worry about that. So what we're going to do first is we're going to set up glue. So to get to your project, if you come into Visual Studio, you can right-click on it and do Open Folder in File Explorer. And what this is going to do is this is going to go through and proceed to show our project layout here, like this. Now you'll notice there's our main file. This is kind of our normal directory. So what we're going to do is we're going to create a new folder called Third Party Libs. And this is where we're going to put all of our third-party libraries again. So now that we have that, what we're going to want to do is we're going to want to take this and we're going to want to make two folders. We're going to make an include folder and we're going to make a lib folder. Now the include is going to include all the headers. The lib folder is going to include the libraries. So we're going to go into include, and the first thing we're going to do is we're going to come over to our include from here and we're going to copy this OpenGL folder into there. Or in this case, move it. So that's the first part. And then we're going to come over to here, and we're going to come to our lib folder. And in this case, we're going to be using Windows 32 versions. Now, this is a 64-bit machine, but this is very, very important to note, is that because of how Visual Studio works, Visual Studio is a 32-bit application. So lo and behold, we need the 32-bit binaries. In the future, when we're deploying, we'll go over how to use the 64-bit versions, but for now, we're just going to come over here and take that like that. So, we have our includes and we have our libraries. Now, you'll notice there's two of them. There's Glue32 and Glue32s. So, Glue32 needs this DLL that I mentioned we don't want to use from before. So, if we go into bin, release, and then either one of those, we have this DLL. The normal 32 version wants to use that DLL. We actually don't need to use that. We actually can get rid of this one completely because we're just doing the static one. And outside of that, we're all set with glue. So now what we need to do is we need to include SDL. So with SDL, and actually, let me go ahead. I'm going to update the title of my stream real quick as well, to include SDL in it. So that's the other thing. So now we need to go through and we need to set up SDL. So we're going to come over here. We're going to go up back to our download section. We're going to go to SDL. And this is going to be another section of things. So again, we have our include. This is all our SDL files. We have our library files, which again are split up into x86 and x64 versions. Now again, we're only going to want the x86 versions, so we're going to go ahead and we're going to take all of this and we're just going to move it on over into here. And the first thing to notice is we have these DLL. We actually need to take the DLL and we need to put that up here into this folder, because when we run our program, it's going to look for any DLLs in this folder here. So we want to make sure our DLLs that have to be used are in there. I'm sure there's ways to statically compile SDL, but I'm not going to worry about that for today's tutorial just because I don't want to deal with it. And again, make sure you're using the x86 version. That's pretty important just because Windows is silly. Next, we need all of our include files. So we're going to come over here, and normally I would just put them on top of there. But what we actually want to do is we want to take these over, and I'm going to actually rename these to SDL2. That way we have our OpenGL files in GL/whatever, and our SDL header files in SDL2/whatever. So we've got all of our stuff ready to go, all of our third-party libraries. Now what we need to do is we need to tell Visual Studio to use these. Right now Visual Studio probably sees the folder in there. If we go over here and we do show all files, you can see it sees the folder, but it doesn't really know what's in them. So what we actually want to do is we want to right-click on our project and go to Properties. Once you open up the Properties file, go down to VC++ directories, and you'll notice two variables. We've got include and we've got library. Include, of course, tells where all the header files are going to be, where it should look and stuff. Library directories are going to be where our library files are going to be found. So we need to tell this to actually look into the appropriate directories for these as well. And it's still going to look at all of the other normal ones for Visual Studio. This doesn't erase those. It just kind of adds extra directories to look into on top of them. So we go ahead, we click on that. I'm going to copy paste the link to save us some time, and then click on the ... We're already in there now, and we can go to include. Now don't click on any of the subdirectories. We want to make sure that we're on this include directory. That way we can still see our folders there when we're organizing our inputs. Go ahead and push OK, then push OK again. And next we're going to move down here. Again, come here and edit. We're going to come over here, paste that again, double click on that. Going to click on lib, and then we're going to select folder. Then we're going to push OK. We're going to apply this, and now it's going to actually be able to include anything from within there. So we've got our directory set up. However, it still does not know what libraries we want to include. It doesn't just automatically include all the libraries in an area. So what we actually need to do now is we need to come down to our input and go to additional dependencies. This lists all of the libraries that are going to be associated with this project, and it's already got some default ones, so we need to add in some extra ones. So if we go to edit, again, this will not actually add in any of the, it won't overwrite the libraries that are needed. It's just going to add in additional libraries to use. So if we come over here to our include folder, you'll see that we have these three libraries. Test is not actually needed in this case. The big ones that we need are Glue32s, SDL2, and SDL2 main. So we're going to come over here and we're going to include SDL2.lib, SDL2 main.lib, and finally we're going to include Glue32s.lib. Now you'll notice I included that last, and that's for a very specific reason. So these three libraries are core, are essential libraries. This is for SDL, this is for Glue. However, there's actually more that we need to include because of the fact that we're using OpenGL. So if you remember, I said that OpenGL, we have to talk to the driver and get the address to function pointers. This is true. But there's actually some other stuff that we still need in order to use OpenGL, because there's some core functions that are given by default that Glue doesn't include, and there's some other little things that we need still. So we actually have to include the Windows OpenGL 32 lib. And this is already set up properly. We don't have to worry about anything else. We don't have to add any additional directories. This is set up in Windows itself. So once you've got that set up, there's one more library we need that's pretty useful to have, and that is the Glue32 library. So once you've gone ahead and you've got those tools right there, go ahead and push OK. Now, some of you watching might know that I've used Glue32s and know that there's something wrong, and we're going to go over that right now. The reason is, remember how I said that Glue32s is a static library? This one right here. So this is static, which means that all of the code for it is included in there, which means when we link it to our project, we want to actually store that so that we can have all those there. That way we don't need the DLL that we got rid of earlier. So what you need to do is you need to come up here to your project and go to preprocessor under the C++ header, under the C++ tab right here. And if you go to preprocessor, you'll notice these preprocessor definitions. So in C++, you can have preprocessor definitions, which basically define variables when you're compiling your code. This is very, very useful if you want to only include things on like Windows or Linux or Mac, so you can detect those. In this case, we already have a few. Thanks. Yeah, I'm glad I could get to a C++ tutorial now then with OpenGL. So with this, we have a few things defined here already. The first is Win32. This specifies that we're on the Windows platform. The second thing we have is debug. This tells us that this is going to be an application that we're debugging, not something that we actually want to release. This is useful for Visual Studio specifically. The final one is console, to let it know, hey, this is a console application. It's not, it's going to have a console window associated with it. And we're going to get rid of that later. We're going to worry about the console stuff later. For now, we're going to leave all of those as is. What we're going to do is we're going to add a new line, and what we're going to add in there is glue static. This tells glue libraries that, hey, everything's going to be static. You need to make sure that you're including everything with it properly. And so we're going to push OK, and we're all set now. So the final thing we need to do is we need a quick little test script in order to test everything out. And just lucky enough, I have actually prepared one before this. So I'm going to go ahead and I'm going to open that up. So let me go ahead and bring this in. And so this is going to open up in Visual Studio. So let me go ahead and make sure I open this properly. And actually what we'll do is we'll just open it this way. So I am going to open it up by pasting that there. And this is going to be our main application. I'm not going to go, well, I can go over this real briefly, but I don't really want to take up too much time with it because, again, we're already 48 minutes into the stream. So I'm going to paste that all in here. And now we're going to come up here and we're going to run this. We're going to say, yes, we want to rebuild. It's going to go through and build. And there we go. There we have some simple, very, very basic rendered OpenGL triangles and squares. When you click on it, it goes ahead and closes. Pretty straightforward. Now this code is all documented. It's a pretty well put together file. However, and this is a key importance. Remember how I said there was a lot of old, ancient, and bad OpenGL APIs you should never use? This is using them. And we're going to go more into how to set up OpenGL for modern OpenGL rendering next time. But this is kind of neat if you want to see some of the stuff that programmers used to use in their games and applications. So this is actually the code for displaying and rendering out the video. And you'll notice the first thing they do is they clear the color. This basically is just clearing the screen. And then here we actually have to clear out the entire system with it. This just sets the color. This actually performs the clearing. And then here we have to load the identity matrix. Now this is, if you remember, I said that with modern OpenGL we have shaders. We can do lots of complex things. This is one of the limitations. This load identity, what it does is it loads a effectively blank matrix. This is great for older things, but nowadays we have tons and tons of different views and setups for everything. We might want to have one for like a left eye in virtual reality and one for a right eye. And so this is really not the best thing to have anymore. But this is what was used way back when. This, of course, moves the scene by a certain amount, and we'll go over all of that later. And then this is the core code. So we have these GL begins, GL ends that I mentioned before. What these basically do is these say, hey, we're starting to draw some kind of shape on the screen. In this case, it's OpenGL's triangles. So we have to specify 3 different vertices. We have the top one, the bottom left, bottom right, and we have to tell it, hey, I'm done drawing my triangle. You're all set. And you can actually use this to draw multiple triangles. You could add in, you could add in 2 triangles and maybe make them off to the side more or something. It's, it's all possible. But this basically, what this does is it moves it a little bit to the left and then tells it to draw a triangle. Then we move it to the right by moving it 3. So we move it back to the center to negate the effects of this -1, and then we move it 1.5 to the left. So it's basically positive 1.5 now. And then we draw our square there, again this time by specifying a quad, and then by passing in the vertices for that quad and then ending it. And then in this case we have to tell, hey, SDL, we're ready to draw everything, and it draws it to the window. And again, this is all very convoluted. A lot of what we want to do now, we don't want to have to worry about specifying individual vertices for every single point. Generally, we have a file that lists out our vertices. why don't we just take all of those vertices, put them into memory, and then point OpenGL to that memory? And that's one of the things that OpenGL's more modern APIs can do. And this is why I say if you see tutorials for this online, stop reading those tutorials. They're out of date. They should not be used. They're just wrong. You don't want to use them. They'll slow down your application. They're going to make you take more time designing your code, and they're just not going to run as well. It's just not good. So this tutorial that we're going to be doing, this whole series for Season 2, the focus is OpenGL, modern OpenGL, making a game. How do you do it? How do you get physics in on it? We're going to be going over virtual reality. I'm going to be using an Oculus Rift come March when my pre-order gets here. I'm also hoping to try and get a hold of an HTC Vive. I have no idea if I'll be able to. If you guys want to say stuff on Twitter, feel free to. That maybe if we can get their attention there, I could get a hold of one, but I'm not really hopeful. I think that they're really focusing on getting big developers who are making games out there with their stuff to make a game. I'm just a small-time guy. I don't have a whole lot of resources, so it makes sense. I'm not too hurt if they don't give me one. But if I can get a hold of one, I'm hoping I can learn it and be able to do both the Oculus Rift and the HTC Vive and be able to show you how to make a game that supports both headsets using proper 3D with OpenGL, how to use a physics engine with it, and all sorts of other fun stuff. So that's really it. I don't want to go past an hour on these videos. Like I said, I want them to be very short, sweet, to the point. If you're watching this on Twitch and you've missed the first half of or something, you can find these videos on YouTube. I will be linking each video to YouTube like I did for last season. You'll be able to watch them there. If you're watching them on YouTube, I stream this every Saturday at 3 p.m. Hopefully today was the last day of technical difficulties. This is a brand new computer with a brand new 1 terabyte solid state drive. It's got a brand new GPU in it and all sorts of other fun stuff. So it's a very powerful capable machine, and I had to set up OBS on it again. So that's all finished. I hope you guys have enjoyed this kind of intro as to what's going on. I hope you guys find this useful. This is a good starting environment for everything, and we'll probably pick this project up next time and start adding on to it. The focus for next time is going to be setting up an SDL window and how do you link that with OpenGL. We'll go over what that all means more in depth next time. If you guys have questions, you're welcome to ask them. I'll be here for just a few minutes here, kind of just talking about some stuff. And if you're looking to follow me on Twitter or YouTube or something, you can find all those links below. It's all pretty straightforward, and I've actually gotten some emails from some of you asking questions about, hey, how do I use Box 2D with SFML? And if you have those questions, post them. I love doing these videos, and I want to know what you guys want. I tried to do a series over the summer on programming and algorithms and such, and I've still got some of that stuff going on. I just haven't had a whole lot of time for it, and I want to make sure it's content that you guys want. I don't want to sit here and just rant about things that I think are useful. If you have something that you want to request, feel free to. That's what I want out of these. I want these to inspire you and to help you to get the resources to make what you would want to make. Show how to make World of Warcraft. That would be a good one, though. Maybe we could do something on networking. I've actually been working on a lot of networking applications recently. I've been working on a positional tracking system for the Gear VR, which I have one of those right here, actually. Maybe we could do something with that. So, again, that's pretty much it for today's tutorial. I hope you guys enjoyed it. Thank you all for tuning in. The lag script, it's good to see you again. Thank you everyone else for joining in. If I've missed people that have been here previously, hi to you all as well. So yeah, if you're watching this on YouTube, again, I stream every Saturday. It's 3 p.m. Eastern Time Standard, noon Pacific Time Standard, and it'll be, 8 p.m. GMT. You can find it on my Twitch stream, which is also linked in the YouTube description of this video. Yeah, thank you guys for tuning in. I hope you guys enjoyed it. I hope you guys found it useful.